Cars, just like houses, have a complex interconnected electrical system inside to function properly. If all these connections were permanent or soldered, what happens when we want to change a light bulb in our house or a headlight in our car? Basically, we will have to cut the wires and splice by soldering more wires.
But do I have to cut and solder every time I want to make a connection or try a different headlight in my car? This sounds very tedious. In today's episode, we're gonna learn about connectors, their types, how to select the right connector for my project safely, and how to create different types of connectors. I'm Juan, and welcome to Master of Juan.
Connectors are mechanical components that link two or more devices. They serve two main functions: reliable transmitting power or signal, and the ability to connect and disconnect easily. In addition to being used in cars, they are also employed in most electronic devices, such as your cell phone with a USB connector or perhaps a headphone jack. This allows you to connect it without worrying about incorrect polarity as many times as you want. There are various types of connectors, such as cable or aerial connectors when you want your connection to be on the same cable. Panel connectors when we want one of the connectors to be fixed on a face or cover. PCB connectors directly solder onto our circuits. And within these, connectors that connect vertically or at right angles. In the world of connections, we also have terminal blocks and ferrules. Their use dramatically helps improve connections. If you're using a terminal block, you can use a fork terminal to adapt better to avoid loose filaments. Ferrules also work, but for closed terminal blocks. Finally, often when we're starting projects, we want to connect and disconnect for testings, and we don't want to install connectors on all our cables, so we can use Wago terminals. With the use of levers, you can do it easily, and they also support a ridiculous amount of current. Now that you understand the importance of connectors and their types, let's choose the right connector for our project. To do this, we need to understand how they work. A connector consists of contacts and the housing. Contacts are metal structures that, when joined, allow the flow of current between them. There's a differentiation between male and female, enabling them to fit together. Contacts also have some mechanisms that allow them to be inserted into plastic housings and latch to avoid accidental disconnections. In some connection types, the contacts come already embedded in the housing. It's crucial to know this mechanism beforehand to understand how to remove the cable if necessary in the future. In general terms, the larger the terminal, the larger the contact area between metals, and the more current it can handle. Also, the larger the housing around it needs to be. So, it all comes down to how much current your system uses. If you want to grasp the fundamental concept of electricity, like voltage, current, and resistance, we have an episode where we explain them in the easiest way. Now you just need to define two aspects: what type of connector you need, cable, panel, or PCB, and how many pins you need. For example, the classic USB cable has 4 pins, 2 for power and 2 for data. Simple LED strips use 2, VCC and ground, and some may use 3 to 5 pins depending of their configuration. This video provides an overview of connectors, but if you want to delve deeper into any particular aspect of this video, don't forget to subscribe and comment. Additionally, in the description, you can join the MakerMail newsletter, where I always send useful information completely free. Okay, we know the current of our system. We've chosen a connector suitable for our current and the type we'll use. If it's a jack connector, you'll probably need to solder it. In the previous episodes of the series, we learned how to solder like professionals at home on a budget, so this shouldn't be a problem. But if it requires the installation of a crimp or terminal, I'll explain the correct method. For this, once again, we'll follow standards and best practices. Most terminals have 2 areas, one for the copper and another to hold the cable insulation. It's important to differentiate them because some terminals only have an area for the copper. To clean them, peel your cable enough so that the exposed copper is only the length that will be held. Leave a very small space at the beginning and end as a margin. Now, use your crimper.
Wait, do I need to purchase another tool? Unfortunately, it's necessary to have a crimping tool for this task. But please, don't use pliers. The pain is not worth it.
The same brands that manufacture connectors usually have their own crimping tools. Look at Molex with the Benefit variant. They have 3 crimpers depending on the cable gauge. Each of these can cost around $500. Or look at this other beauty. A crimper that has a very elegant mechanisms to allow the fit of crimps and costs an outrageous $3,500.
Certainly, these tools have their advantage in a demanding professional environment, but we just can't afford to buy one for each type of connector we'll use. So, I'll bring to you the solution.
This generic crimping tool comes with different dies for almost all applications you'll use. But if you plan to use very small crimps, you'll need this other one. Choose the correct die for your connector. Gently latch the crimper terminal to keep it in place the cable, and press it all the way. The copper area should be completely surrounded by the crimp, with no loose filaments. Similarly, the insulated area should be securely held. This is the ideal crimped terminal. And, if done right, there's practically no difference with a crimper over 10 times its price. This crimper can be used for a wide variety of terminals and sizes, like the ones we saw at the beginning of the video. The same principle applies to the other crimper, only this time you'll need to press the copper area and the insulation area separately. I won't lie to you, it takes a bit of practice. You might mess around 4 or 5 crimps, but after that, it's a piece of cake. Now that you have your cables crimped, you can insert them into the housing. What if you made a mistake and placed it in the wrong position? For this, you must have understood how the clamping mechanisms work. Depending on the model, use tweezers or these generic tools. And, with patience, leverage to deactivate the connector's clamping mechanisms so you can remove the crimp intact. This may require a bit more practice for some connectors, but learning it totally worth it and will save you for any trouble in the near future.
Connectors are crucial for our projects and often overlooked. Just like this, there's another topic that makers don't consider, and it's literally the essence of every project. Click here to discover more about it.